The next term is the imperfect testing term. Originally, in the early days of SIS design, there was an assumption that when you performed the manual proof test, that it would identify 100% of any failures, any dangerous failure modes that could occur in the system. Well, depending on the rigorousness of your testing regime and the types of components you're using, the service you're installing them in, use of the assumption of 100% effective manual proof testing is a bit optimistic. And with the 2016 version of the IEC 61511 standard, you're specifically required to consider what manual proof test coverage am I actually achieving, and that needs to be considered in your calculations and entered in. So with respect to the Vertigo calculations, by default there's an assumption of perfect testing because the imperfect testing button is not checked, so you need to enter that information yourself. So when you want to consider imperfect testing, you begin by clicking the imperfect testing button, and you'll see it's trying now to calculate a Pfd average, but it's still looking for more information. So in order to calculate imperfect testing for each component, you first need to determine, well, what is the coverage of the manual proof test? So I'll say 95% or 0.95 is the fraction that could be detected by a manual proof test. And then you'll need to enter in the useful life of the device, because the useful life, the imperfect testing failures accumulate over the entire useful life. So for useful life, you're going to enter in the amount of time you expect that equipment to be in service. So for sensors and logic solvers, you're usually looking at the lifetime of electronics, perhaps 25 to 30 years. And for things like valves, you're looking at a major overhaul period where the valve is taken out of service and completely rebuilt and returned to good as new condition. So you put the useful life in, the proof test coverage in, and then you're going to see a calculation of the Pfd average. So in this case, we're calculating all of the components of the Pfd. So the Pfd of the overall subsystem is the summation of each of the individual components. And in this case, you'll see there are 5 components that contribute to the Pfd average of the component, and 3 terms that contribute to the spurious trip rate of the component. And they all get added together, summed up to give you summary Pfd and summary spurious trip rate for an individual component.